to do is do a quick explanation of yesterday again in half the time. So let's have a look at distance between 2 points. Coordinate geometry, 2D, point A, point B, doesn't matter where they are. We label them x1, y1, and x2, y2. And we just do that because it's convenient, because we can expand it to as many things as we want. Now, the first formula, the distance formula. What is the distance between those two? Short answer, we set up a right angle triangle.
D equals A squared plus B.
And yeah, there's a small voice over in the back there. This distance is the hypotenuse of a right angle triangle. We know what Pythagoras is, so therefore we look at this length, this one, obviously squared, this one squared, and so all we have to do really, and this is where the formula comes from, Pythagoras says d squared, the hypotenuse squared, is the vertical bit, which is the difference between the y's, which is, well, we'll do the x's, or it doesn't really matter which order, but we'll do the x's first, I guess. x2 take away x1 squared, that's this length, squared, x2 is way over on the right-hand side, etc., plus y2 minus y1 squared. Pythagoras, h squared equals a squared plus b squared. It's just the right angle triangle thing, very straightforward. And notice that I've written x2 minus x1, whereas the formula, the official formula, and I'll just move this up a bit, not you, up to there, put those there. Now, the formula in the book says d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, why can we write x1 minus x2 or x2 minus x1? Why is it the same thing?
We did it the other day.
Yeah, I know we did it the other day, but why does it work both ways around? Because you're squaring it. Okay, if you consider this, 2 minus 5, that says 2 minus 5, as an example. 2 minus 5, or 5 minus 2. 2 minus 5 gives negative 3. Negative 3 squared is 9. 5 minus 2 is 3. 3 squared is 9. Same difference. Because we're squaring it, the sign thing doesn't make any difference. So the formula is x1 minus x2, y1 minus y2, but geometrically, it's just the lengths of the sides of that right angle triangle. Now this doesn't mean that we have to go and draw it every time. Knowing this, it's the difference between the x's and the difference between the y's. Knowing that, then if you have a question which says point A is 6 minus 2 and point B is minus 3, 11, what's the distance between them? You don't have to draw it because we know that our formula, and I don't think you're given it on the, no, you're not given it on the formula sheet anymore because you're expected to remember what Pythagoras is. Knowing that it's the difference between the x's and the difference between the y's, then the 6 and the negative 3 are the x's. So as long as you're consistent and go, say, the top ones minus the bottom ones, what does 6 take away negative 3? 9. So our formula says it's the square root of the difference between the x's squared and the difference between the y's. What's negative 2 take away 11? Minus 13. Minus 13 squared is positive 169. Oh, in fact, it's 13 squared 169, just from memory. And you get that. And then you just get your calculator out, or you might already have it out to have worked out 13 squared. But anyway, you just work it out. So we don't have to draw it, but sometimes drawing the little diagram makes a bit of a difference. For instance, there was a question which I was asked yesterday, And the question was, what is the distance of the point minus 5, 20 something? Well, let's just make it 21 from the origin. Distance. Was it negative 521 or? Negative 724. Oh yeah, I was close. Not really. Negative 724. And the reason why 7 and 24 are used is that you'll see shortly. Now, that's not an unreasonable one to draw because, just to get an idea, the origin, of course, means here. That's the origin. 0, 0 is the origin. Negative 724 is 7 backwards, 24. So either you picture that in your head or you draw it and you get that. And the question is, how far is it from here to here? Now, because we've drawn it, that's just a simple right angle triangle question. This distance here, that's 7, that's 24. Pythagoras, we don't have to worry about that great big formula because this is 0, 0, so it makes it nice and easy. D squared equals 7 squared plus 24 squared. D equals the square root of all of that stuff, which is, that's a 5. I think you'll find if you do it on your calculator, you'll get exactly 25. Yep.
Even though it's like going back 7, so it's negative 7, do you still just go positive 7 squared?
Yeah, well, see, this is the thing. A triangle can't have negative sides, can it? A triangle if you draw a triangle, then its side lengths are lengths. They are positive numbers. Just because its coordinate is negative 7, positive 24, it's still a 7, 24 something triangle, isn't it? Yeah. Okay. What I want you to do is to solve these problems in two ways. If you're just given a couple of points and told, work out the distance, okay, then just chuck it into the formula. D equals square root of x1 minus x2, in other words, the difference of the x's squared and the difference. Just do that, just like I did before. 6 take away that's 9, 9 squared. Negative 2 take away that is negative 13 squared. And then work it out, okay? In other words, there's no geometry there. There's no triangles really. There's just a couple of points in two-dimensional space, and we just use a formula to come up with a distance, and it doesn't really have any geometrical sort of sense or context. Whereas this one, if you draw it and you see this triangle here, that's an actual triangle. And if someone said, what's the hypotenuse of an actual triangle, you would just use Pythagoras, which is what I did.
The one before on slide 4.
Yep.
When you use the formula at the top, would you then use negative 13?
Absolutely.
Yeah.
But I drop the negatives because a negative squared becomes a positive anyway, doesn't it?
Yeah.
So this, I wrote down 13 there, even though I went negative 2 minus 11 is negative 13. I didn't bother writing negative 13. I probably should have done that, because that's what is consistent with what I did over here, okay? But because I knew the negative was not going to matter because I was just going to square it, I just ignored it.
Yeah.
You're literally after this formula here is the distance is the square root of the actual physical difference between the points, and that's a positive amount. The difference is always positive, isn't it? You could think of it. It doesn't really matter whether it's x1 minus x2 or x2 minus x1. Because we're going to square it, we can treat it like the physical difference between the 2 points. And the physical difference between those is 13, these ones. And the physical difference between those is 9. And as long as we use 9 and 13, we're going to get the right answer. Okay.